project by another customer, a new customer, Alcatel Lucent Labs. My customer is here today, and this is Team 5 on automotive.
Greetings, everyone. My name is Tristan. This is Team 5. This is Sean here, Nicole, Pablo, and Dulce. So our client, Alcatel Lucent, has designed a multimodal, sensor-equipped room referred to as iRoom, designed to implement personalization technology, which consists of an environment that recognizes the visitor through a variety of methods. These methods include sensors that actively register the number of individuals in the room, and a face recognition system that enables the room to react and adjust based on the identity of the visitor. So, some visitors will have RFID tags, which is also another way of identifying them. This information is encapsulated in the form of a string that is output by the system, the room, which is the result of the sensors and the face recognition system, the RFID tags, working collectively to identify the visitor. So this is just an overview of the iRoom server dashboard. This is not our work, but this is what is featured in the iRoom. So a quick overview of the interface. Now, this is where we come in. We were asked by Alcatel Lucent to design 2 computerized modules that would enable the actuation of the blinds and the dimmer switch based on the identity of this visitor. So if I walk in and I want the shutters to be half tilt, the dimmers to be, let's say, 90%, then you'd have these, the face recognition system and the sensors would then send an output to our system, which would then adjust the blinds accordingly. So this is just a basic overview of our deliverables. We have a lights unit or lighting module, which would be retrofitted over the dimmer switch, an Android app, which was actually desired and optional, but we decided to go through with that, and a blinds unit, which would be also attached to the blinds, just a rough actuation. So some of the requirements, so below 5 watts of power consumption, 3 by 5 by 1/2 inches dimensions. Again, this needs to be retrofitted over the existing lights and ribbons. So how it works, we have this central PC that allocates, I guess, signals, or not signals, but information. So we have the iRoom, which has this input string. We have our Android app, which can also send instructions to the central PC, which will then allocate instructions to our lighting module. So the central PC is very important in our central design.
So, as Tristan said, my name is Sean, and my role on the team was mechanical design, so I'm going to talk to you a little bit about that. Here's some pictures of our 3 units. Well, 2 hardware units, the blinds on the left, the lights on the right, and the center is just the main menu for our app. So, the blinds module. It consists of a case which is about 3 inches by 2 inches by 1/2 inch. That's the housing for our driver and controller. A platform that comes out, on which stands a motor and potentiometer, which have 2 interlocking gears so that they can interact, and a cylinder which sits on top of the motor gear. So installation simply requires that it's placed onto the metal wall because it has magnets in the back, and the blinds rod is placed into that metal cylinder that you see, and then tightened with a set screw. And what's great about this is that it allows for manual control even when it's installed. The blinds rod one can still turn it, and the potentiometer means that our system will continue to know the position of the blinds rod even when it's turned. And in terms of power consumption, it easily meets the requirements. When it's idle, which is the vast majority of the time, it's only consuming about 0.4 watts. And when it is turning, it's consuming 7.2 watts, which is above 5, but on average, it comes out to much less than 5. So here's our lights module. That's just a little bit of the inside. This consists of a motor with a gear attached again, and a linear actuator which sits above it. The linear actuator is used to push the light on because it's a push on and off light, and the motor is used to turn it. One would have to remove the dial from the dimmer that comes off and place a gear onto it, which the motor gear can interact with. And the power consumption for this also meets the requirements. When it's idle, it's about 0.9 watts. When the linear actuator is pushing, which is only about a second or two, it's 3.4 watts. And when the motor is turning it, it's, again, 7.2 watts. But on average, it comes out to much less than 5 watts. So here's just an overview of the hardware that we used with the reasons why we chose it. And now Pablo's going to talk a little bit about the system control.
Okay, so the system consists of a main program that is written in C#. This is going to be a server that's going to be in the room. Now, this program basically accomplishes the communication between all the parts of the project, so it runs together. It is a program with a main function and then 3 simple threads. The main function, well, obviously just sets the variables, gets everything ready. Then the first thread is going to receive data from the Android application. So the user is going to input their desired levels of the lights and the blinds, and it's going to go to the server. And this thread is going to take care of obtaining that information and accordingly sending the data to the microcontroller so they can move the motors and perform the desired action. The thread number 2 receives the data from the iRoom. And the iRoom has a software that basically has feedback for the lights. And it updates every single second. And it's gonna work by connecting both our software and their software through a UDP software. And this updated data is going to be updated every second. And this way we're going to know what the position of the lights is so that we can send an appropriate command so the lights go to the desired level. Then thread number 3 is going to receive the feedback from the blinds. There's feedback given by the iRoom for the lights, but there's no feedback for the blinds. So this is something we did ourselves with a potentiometer. Potentiometer calculates the level of the blinds based on voltage, and then it updates it and sends it to the server. So we have the data updated, and the user can also see it in the Android application. Now, each thread receives a specific command. The iRoom is simply a string that's predefined by the customer. It's a pretty long string, but we only need certain data, just like the level of the lights and a timestamp. Then the app string and the potentiometer string is a pretty simple string that we created. Nicole's going to talk about that later. Okay, that's pretty much everything about the server. Then there's the code for the microcontrollers. So what we're using is used RF-enabled MSP430, and we also have a USB developing port that you connect to the server. So what's going to happen is the USB is going to be connected, and then an MSP430 is going to be connected to this USB. And there's going to be communication between the code in the server and this MSP430 through a virtual serial port. Now, this to communicate, user types the command, server gets it, then the microcontroller attached to the computer gets it, and then it sends the command to either the blinds microcontroller or the lights microcontroller. And then after this, the microcontroller will send an acknowledgement packet back to the server so that, well, there's reliability in the delivery of data.
Now there were, as previously mentioned, there were dimensional constraints that we needed to adhere to. So the PCB was designed, the primary function of the PCB is voltage regulation for the RF25 board. So what I've included was a 3-step VN to 5 volt, 3.3 volt step-down regulation, which is the required power or voltage to drive the RF25. It's a very simple design. We had dimensional constraints, so we couldn't really integrate all of the components into one board. So we needed to, just pick a specific function and have the PCB do that. And that's just a basic schematic. Again, 2 voltage regulators.
Okay, now for the Android app, we decided to use it for writing using Eclipse and Java. It's a very simple app. You have basically 5 screens. You have a splash screen that it pops up whenever the user first enters the app. It basically displays all the information about us and about our client. From the main menu, you can also access an info screen, which elaborates a little bit more on what we're doing, what our project is about, and who we're working with. And then you get to the main menu. You basically, using the 2 image buttons, the user can choose whether to set the blinds or the lights. For the blinds, we're just using a simple seek bar. The user can set the percentage of the tilting of the blinds. So if he wants it in 50%, he'll just drag the seek bar to 50%. It'll display, as you drag the seek bar, it'll display the value so the user can know. And then you just hit the apply button and it gets sent to the MSP and that'll move it. And for the lights, we created a seek bar that goes, it starts off at 0 and then you can go up to -100 and +100. If you want to turn the lights up, say 50%, you just drag the bar to the positive side, 50%. If you want to turn them back down 30%, say, just drag it to the negative side 30%, and it'll adjust according to what you want.
Okay, and I handled the back end of the app, which was the communication from the PC to the app. There's a server that Pablo was talking about earlier, which is ready to receive the packets on the PC. Instead of using the UDP like we talked about earlier, which receives the string to the IRA, we're using TCP packets. In which case, from the app, we hard code the IP address and the port number directly into our code. So we know that it is getting sent to that server and that server only. And it does not need any feedback communication. So as Dulce mentioned, the packet is sent not when the user is scrolling on the seek bar, but actually on the send button or the apply button. So after that package is sent, the percentage and the direction that was adjusted displays on the screen. So the user will see that, hey, you changed it 30% to the right. In the Android, the string that's sent from the Android app, the server will be set up to receive this specific type of string. And if it receives anything that's not within this specific format, it will produce an error or just will not work. So if the lights are going to turn clockwise, the string is an L, an uppercase L, followed by 3 digits. So like the example, L030 is going to turn the dimmer 30% clockwise. If we're going to turn the lights counterclockwise, which is turning it down, we reserve a K. We're going to send K in 3 digits. It has to be either an L or K, and it has to be followed by 3 digits. And if the app is at 0, then that's the push on and off action of the light. So that'll turn it on and off is when it's set to 0. And for the blinds, we do not actually need to specify either direction because of the potentiometer feedback. So for the blinds, it's actually a little more complicated because we need to be able to receive information from the server. So instead of setting the percentage based on where you currently are, you set your desired percentage, and based on the feedback from the potentiometer to the server and the server to the app, then you know how far to move the blinds. And special thanks, Hawk, our customer who actually made it today. David Campbell, who machined our cases for us, and Professor Carney, who helped us a lot with mechanical design, helped Sean out a lot.
So did you say if a person walks in this room, the computer recognizes him and knows how he wants to set the blinds automatically?
That's correct, but that was not part of the system that we designed. That was part of what the IRA built out.
How does the computer know how I would want to set the blinds anyway?
They're preset. So that's just some background information for you guys, but the IRM in Bell Labs It's mostly the employees there, where they have their settings preset, so they can be recognized either by the facial recognition system they have down there, or an RFID card on their employee ID, and sometimes even their smartphone that they're carrying. They know who it is, and based on settings that were preset by their terms, not ours, then they know how to like the settings.
Did you get a chance to kind of test your system out and check the actual item, or?
No, unfortunately did not. Only I was able to even make it there. So for a test setup, we have it on a dip-in dimmer and blinds that we had to buy because, you know, we can't take you all to New Jersey.
Is there any other technology on the market right now that does something similar, and is that something that you looked into initially, or I guess what is the part that's unique in terms of your implementation that required kind of custom hardware and software?
Well, the thing is, we designed both of these modules with the specific needs of the iRoom in mind. It's pretty much just for their sole purpose. As of now, people can't use it in their homes, or you can't buy it as a separate system. So it's basically just for them, and it works just for their.
However, I think in the future, what's the understanding of some things that currently exist is the fact that we are retrofitting it on top of, so it does not require any internal electronics. You don't need to, the installation process is very easy. Especially for the blinds too, because
So as opposed to, you know, I've seen some fancier rooms where they have automatic setup, you know, remote control blinds and lights actuation, but that of course requires the room being special, whereas our components are the sort of things that down the line anyone could just fit over their own lights or different solid blinds. Professor Kia, do you have a question?
I just had a question. It was so you right now you have a server that's controlling all of this, right? And an ECE. How many of these components can you consolidate into one thing so that when you walk in, all you need is just one or two components, such as just a phone or maybe not even a phone. So ultimately, I'm just asking, what's the ultimate level of integration that you can reach? So would it be sufficient at the end just to have your blinds and then the iRoom central server would talk to you?
Oh, that probably has to do with more about the functioning of the iRoom itself. The way it's set up is that the iRoom is kind of like a data collection sensor where it uses facial recognition, RFID, and it has a personal database of people's personal preferences, and then it sends that using the local Wi-Fi number to like a PC and the server in the room. Further integration would require I guess a change in the way the iRoom works, because our system was designed specifically for.
We could adjust. I mean, we would have to work specifically with the
Right,
iRoom to integrate. So.
Right, but as of now, our system simply requires plugging in the development board via USB. Chris?
Does the Android app specifically, or does it change the user's preset conditions so that when the user enters the room, or is it just one time?
the Android app isn't even necessarily for a user who has predefined specifications. Anyone who can download the app and use it in the room. So no, it won't change at all. It just was going to change the current settings. It's, I guess, equivalent to walking over. Instead of getting off the couch and walking over and turning the light, you hit the app instead.
Small follow-up. So is there any sort of security that stops someone from downloading the app just to screw with the people at Alcatel Lucent?
Well, they would have to have broken into Bell Labs at that point, I guess.
And yeah, also you have to have the IP address of the server that we're using, which is as of now it's hard coded into our code.
Okay. Do you have to be in the room though, or is
No.
it? So it doesn't say like, oh, you're in the room and you have the app.
Oh, you don't have to be in the, no, not in the room.
You just have to have the Wi-Fi.
Yeah.
What would you say is your biggest challenge?
Mechanics.
Okay. Yeah, the mechanical part was difficult because none of us are mechanical engineers, so I think particularly attachment to the blinds, and additionally the pushing of the dimmer as opposed to it being a turn on and off. It just meant that we needed that extra component of the linear actuator, and just placing with the gear just made the module a little bigger than desired and heavier, bulkier, just changing the space requirements.
Well, it says you have RF microprocessor, so I take it all the links were RF? Nothing was hardwired between the different links, it's all RF?
Everything's RF.
Did you have to do any design work with this, or is that all just automatically taken care of?
Well, we use the MSP 430 is the ECE 430 RF 2500. It's pretty straightforward. It has its own protocols that's to use, but it's not that reliable. So we did have to kind of try to make it as reliable as possible with acknowledgement packets and stuff like that. But yeah, that was actually one of the harder parts too, along with the mechanical part of the project.
Was it for one of each only?
Yes,
Yeah.
One of each, that's it?
Yes,
Yeah.
at this stage, yes.
Yeah.
All right, thank you.